Now here we're going to start take a look at what happens with reactions in aqueous solutions. For what we do in general chemistry, pretty much everything that we do is going to take place in water. And so we need to consider and think about the properties of different things that can happen when we're working in an aqueous solution. Now it's important that we be familiar first with these two terms. Any solution is made up of two substances. A solute, this is the item that's there in smaller quantities, and is the one that gets dissolved. And the solute can typically be a liquid, solid, or even a gas. Solvent is almost always a liquid, and it's the component that does the dissolving, and it's the component that's available in the solution in larger quantities. Now, water itself is a very important solvent, and it serves that role because of the properties that it has as a compound. So water has essentially this basic shape, oxygen in the middle, and the two hydrogens attached to it. As we'll learn later on in the course, the geometry is what we call bent, so it's not straight across, but these bonds here are bent in slightly. But most importantly for today, hydrogen has less attraction for electrons than oxygen. And because of that, that means these electrons in the bonds between hydrogen and oxygen, while they're shared, these are not ionic bonds. Recall, ionic bonds are when one element gives the electrons to the other element, and then we have two charged species. That's not the case in water or in the oxygen-hydrogen bond. However, because hydrogen has less attraction for these electrons than oxygen does, the electrons are not shared equally. And so they're more sort of pulled more towards oxygen than they are to hydrogen. What this results in is not two ions or three ions here, but it ends up being what we call a polar species, where we use this lowercase delta to indicate that there's a partial charge. So we would say there's a partial charge on oxygen, partial negative, and partial positive charges on each of these hydrogens. Overall, this does tell us that water is a polar solvent. And therefore, if we add an ionic compound to it, not only do they dissolve in water, but they do what we call dissociate as well. Now, what does that mean for something to dissociate? So if we took an ionic compound, such as sodium chloride, which is a solid, and we add it to water, Very likely you already know that if you add sodium chloride to water, it's going to dissolve. But what actually happens when it dissolves? Well, these two ions, the sodium plus and the chlorine minus, will actually dissociate. Meaning they're potentially not as close together as they were. And the reason that they're able to do that is if we think about the polarity of the water molecule we just discussed, the oxygen part of the water molecule is negatively polarized, and so those oxygens are able to surround the cation, the sodium, and then the hydrogen, which is the positive end of our dipole or of our polar molecule, it's able to surround the chloride ions. And that allows for these sodium and chloride ions to dissociate, or essentially to pull away from each other. So we have various compounds that we work with, which we can refer to as electrolytes. So first question, what is an electrolyte? An electrolyte is defined as a chemical that produces ions and carries an electrical charge when in solution. And we can divide compounds up into what we would call strong, weak, and then the third category we call non-electrolytes. So a strong electrolyte is a compound that dissolves or dissociates fully in solution. And we're going to focus here on just water. So all of the examples I show will be applicable to water. And this includes examples of things such as HCl, hydrochloric acid, nitric acid, potassium hydroxide, or the example we showed above, sodium chloride. A weak electrolyte is a compound that partially dissociates. And this can include things such as acetic acid, hydrofluoric acid, or ammonia. Now, without getting into things we haven't covered yet, but just to provide some additional information if you have seen these things. If you're familiar with weak acids or weak bases, strong acids, strong bases, you'll see that there's a lot of overlap between strong acids and strong electrolytes, strong bases and strong electrolytes, and the same thing for weak. Many weak acids and weak bases are weak electrolytes. Our final thing, non-electrolytes, these are molecular species. That do not dissociate at all. And might include examples such as various sugars like glucose or sucrose or something like ethanol.